Hey there, this is Mr. Alexander, and I'm going to walk you through the notes from Day 2 of Unit 9 over characteristics of radical functions and doing inverses a little bit more, just like we did last time. I want to start with the square root function, and I want to fill in a table. I'm going to change this to negative 36 real quick. The easiest way to fill in a table is to simply plug the x into the function here. So the square root of negative 36, hopefully you remember, is 6i. The square root of negative 25 is 5i. Square root of negative 16 is 4i, 3i, 2i, 1i, or just I if you prefer. And then the square root of 0 is 0. Square root of 1 is 1. Square root of 2 is the square root of 2. Square root of 4 is 2, 3, 4, 5, and 6. Now from this table of values, I'm going to graph this function, the square root of x, on the Cartesian plane, which of course is the xy plane. And on the xy plane there are no i's at all. You need to graph those i's on the complex axis, and I'm not going to show you how to do that today. So we're only going to plot the points that do not have i's in them, starting with 0, 0, and then 1, 1, 4, 2, and the last one I can graph is 9, 3. So the square root function kind of looks like half of a sideways parabola, just like that. And from this graph, I can identify the domain, range, x-intercepts, y-intercepts, all the other characteristics we haven't talked about yet. So domain, remember, is how far left to how far right. And this thing goes from 0 to infinity on the x-axis here. It actually touches 0, so I'm going to use a square bracket. It does not touch infinity, so I'm going to use a round bracket. The range is the same, how low to how high. This thing goes down to 0, it actually touches 0, and then it goes up to infinity, but it doesn't touch infinity. The x-intercept is simply where this thing touches the x-axis, which is 0, 0. The y-intercept is where it touches the y-axis, which of course is also 0, 0. The maximum is the highest point on the graph. This one does not have a maximum because it's going to go up forever. So there is no maximum. However, it does have a minimum, which is the lowest point on the graph. It's right there at 0, 0. An asymptote. Does this thing have an asymptote? Remember, an asymptote is simply a line that this function approaches but does not touch. Now, you might be inclined to say that the x-axis is an asymptote here, and you'd be right if this was an open dot, if it didn't actually touch 0, 0. But since it does touch 0, 0, there's no asymptote there. In fact, there's no asymptote at all. Now, when you're analyzing this graph, as x decreases, meaning as you move to the left, what's the y doing? Well, the y decreases as well. And as the x increases, meaning we're moving to the right, what's the y doing? Well, that y is increasing. So that's all the characteristic that should say increases. Those are all the characteristics for the square root function. Now I want to talk about the cube root function. And if you don't know how to get the cube root on your calculator, because you're trying to calculate these, then let me show you that real quick. All you want to do is, let me turn on this calculator first. On. And if you hit the math button, it's math 4. So that's the cube root, and I'm going to go ahead and type in negative 216, close parentheses, enter. That's just negative 6. And so I'll go ahead and plug that in there. The cube root of negative, sorry, I just messed up my window here. The cube root of negative 125 is negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Excuse me. So I fill in this table for the cube root function, cube root of x, and I'm just going to plot all the points that I can. So I'm going to start with negative 2, negative 8, negative 2. Then I'm going to plot negative 1, 0, 0, 1, 1, and the last one I can plot is 8, 2. And remember, these just like a cube root has a little wiggle to it. It's just kind of wiggling on its side. So I'm going to, as I draw this, I'm going to try and capture that wiggle there. And that's what the cube root function looks like. Now, just like a cubic, the domain range for all cube roots are all real numbers. So that's pretty easy to remember. For cube roots, the domain range is always all real numbers. The thing crosses the x-axis and the y-axis the same place at 0, 0. This thing's going up and to the right forever, so there's not a maximum. And it's going down and to the left forever, so there's no minimum. And since we touch every single x and every single y with this function, of course there's no asymptote either. As x decreases, y is decreasing with it. And as x increases, y is also increasing. As x increases, y increases. As x decreases, y decreases. So what do they have in common? What's the same about these things? Well, the x and y intercepts are the same. And is there anything else that's the same? I'm not going to mention the nones for the maximums because they don't either have a maximum, they don't have an asymptote. So I guess we could also say the x and y increasing / decreasing relationship. That's the same as well. Now the things that are different are the domain and range. And what else is different on here? It looks like the square root function has a minimum, and the cube root does not. So I'm going to put min right there as well. Those are all the differences. Now that we've talked about the square and cube root function, we're going to apply what we did last class to try and figure some things out here. So what I'm going to do is I've got a function. I want to find the inverse. But before I do, I'm going to state the domain and range of the function. I'm going to find the inverse, state the domain and range of that, and then say whether or not it's a function. And if it's not, then I'm going to restrict the domain on the original. So, domain and range for this guy, negative x plus 4 squared plus 1. Easiest thing to do here, folks, let's just graph this thing. Let's say negative x plus, plus 4 parentheses squared plus 1. Graph this thing. How high does it go? How low does it go? You might be asking, hey, what's that vertex point right there? Well, I can tell from the equation. This says left 4, up 1. That plus 4 says left 4. That plus 1 says up 1. So I know the coordinate of the vertex is negative 4, 1. So when I'm writing the domain, I know that it goes, well, first off, it's going, come back. It's going to go left forever and right forever, so the domain of this thing is all real numbers, but the range is how low to how high, and it goes down to negative infinity, doesn't touch it, and it goes up to positive 1, and does touch it. That's what this plus 1 right here says, that it goes up plus 1. Now, remember that the coordinate of this thing is negative 4, 1, because that's going to be important in just a moment here. So when we're finding the inverse, we're switching the x and the y. X equals negative y plus 4 squared plus 1. I'm going to start by subtracting the 1. X minus 1 equals negative y plus 4 squared. Get rid of the negative by multiplying both sides by negative 1. Negative x plus 1 equals y plus 4 squared. To get rid of the square, take the square root of both sides. Y plus 4 equals the square root of negative x plus 1. Don't forget, when you take a square root, you've always got the positive and negative solution. The last step here, subtract the 4. Y equals square root positive negative x plus 1 minus 4. I'm going to state the domain and range now. Domain, range. The domain of this thing and the range of this thing are simply the domain and the range of the original function except swapped. So the range here becomes the domain here. And the domain here becomes the range here. The question is this thing a function? Is the inverse a function? The answer is no. The dead giveaway is the plus and minus there. So we're going to say it's not a function. But it could be if we restricted domain of the original. Not a function unless the domain of f of x is restricted to, and this is where we need to split this parabola in half. So the domain is the x value. So what's the x value that cuts this thing in half? Well, that's -4. So we can restrict it to either -infinity to +4, or sorry, -4, or we can make it -4 to +infinity. That's the only way to make the thing a function, is if we split it in half to start with. And I'll show you how to restrict that domain on your calculator on the next problem. But let's go ahead and do this next one now. This g of x equals the square root of x minus 1 plus 2. Again, easy way to get the domain and range is to simply graph it, which I'm going to do. So the square root of x minus 1 parentheses plus 2. Graph this thing. You can see that it starts right here and goes off to the right and up forever. Question is, what's this point? Get that from the equation. This says right 1 up 2. So that point right there must be 1, 2. So the domain, it's going to start at the x value of 1, and it's going to go to the right forever. The range, it's going to start at the y value of 2, and it's going to go up forever. Now, to find the inverse, we're going to flip the x and the y. We're going to get y equals the square root of y minus 1 plus 2. And I'm going to subtract the 2. I'm going to get x minus 2 equals the square root of y minus 1. I'm going to square both sides to get rid of the square root. Y minus 1 equals x minus 2 squared. Last step, add the 1. Y equals x minus 2 squared plus 1. And state the domain and range. Domain, range. Remember, you just flip them now. 2, infinity, and 1, infinity. And this thing is definitely a function. It's a quadratic. So I'm going to write it in function notation. G of x equals x minus 2 squared plus 1. And I can write it in function notation because it's a function. Now, there's something about this that might be a little disturbing to you. You'll notice that we've got a quadratic with a domain that's not all real numbers. And I want to show you why that happens. If I go to y equals here and I just type in the second equation, x minus 2 squared plus 1. And then I do the line of symmetry, y equals x. And if I graph those, it should be symmetric along the lines y equals x. But it's not. You can clearly see there's too much of this parabola here. It's like we've got twice as much parabola than we need. The way we can do that in the calculator, we can restrict that by going to the second equation, putting the whole thing in parentheses here. Second insert parentheses. And then we can put a domain restriction in here. If we do parentheses x, you want to do second math greater than or equal to. And we said the domain, it starts at it starts at 2. So I'm going to type a 2 in there. And if I close that parentheses and now graph it, take a look at it now. There's the square root. There's the restricted domain parabola. There's the line of symmetry. And look at that. It does look like an inverse. So here's the big idea from today. Since the square root has an implied domain restriction, the inverse, even though it's a quadratic, also has an implied domain restriction. They both do. Since the square root starts out with a domain restriction, the inverse must also have a domain restriction. It also has a range restriction. And that's why this quadratic function isn't all real numbers for the domain. All right, that's all for now. Thanks for watching. We'll see you next time.